All right, where were we? We were in emission shapes. For now, let's go with point. All right, and we probably don't need 256. Other fun things. Direction. Now, I've got gravity off at the moment. Direction is which direction should it be going in and how much spread. Let's turn the spread to 0. And right now, you'll notice it's not moving. It knows that it should be moving to the right, but it isn't. To see it moving to the right, let's go down to initial velocity and pick a velocity of, let's say, 250. Now it's moving, but it's really jerky. And the reason it's jerky is the moment it's out of time, it despawns and the next one will spawn in. Now there's stuff we can do to make that look better in a minute.
So it's not actually jerky; it's an optical illusion because the last one's just dying. It's not fading out or shrinking to nothing.
If I put in not 23, if I put in 2, it's much more obvious, right? After the time has run out, and it's not the distance, it's just the time, the next one will spawn in.
You could literally animate some signs at this point, couldn't you?
You absolutely could. And if you're using a sprite sheet, you can use the animation thing here to pick which cell you want. So you can have like all kinds of moving stuff.
Oh, you can have it change at the like on the 4th iteration.
That's how we deal with the bubbles in not Tuki Bubble.
Nice.
The bubbly game. Yeah, Tuki Bubble.
Yeah.
When they pop, I've got one image with all 10 colors. It just picks the frame.
Yeah. Well, that's awesome.
Much easier. Okay, so we've got our initial velocity. Let's turn that back to 0. There's a few others. We've got angular velocity. How much is it going to spin? This is a circle. That's not going to help us. Let's change that to a different texture. Let's go to a square. Okay.
Oh, so it spins the particle, not its direction of movement.
Correct.
Got it.
So right now we have 8 squares on top of each other over 2 seconds. Not helpful. So if we go down to our angular velocity, and let's say I want an angular velocity of 10. Let's say I want an angular velocity of 500. Okay, find a nice even one. So already we're starting to get some fun effects. Now, again, we can randomize this depending on how chaotic you want. And we start getting something a little bit more organic, right? So there's already some fun stuff we can do just by playing with these. Then there's orbital velocity. Now, orbital velocity is probably not going to work here. Yeah, it's not going to work here because we're all at the same point. We're trying to orbit the point we're at. And if you're at that point, orbit is 0. So let's go back to our emission shape. By the way, once I've gone through all these, we will start playing around and making some fun stuff. This is just groundwork. Don't worry. This is not the whole thing. Where's my mission shape? Let's go to sphere. And let's put you at 100. Oh, that's painful.
It's rather scatty, isn't it?
I think my orbit velocity is way too high. There we go.
Nice.
And again, you can randomize it. Now, one thing you'll have noticed with all of these, and this is true for those, is we have a curve. We can go to a curve texture, and instead of having a velocity of 1, we can say my minimum value is 0, my max is 2. I want you to start by not moving. I want you to orbit, and then I want you to stop.
Nice.
And let's just have 2 so we can see what's happening here.
I've got so many things going around in my mind how I could use these.
Right. Just by understanding these, you can get all kinds of cool effects. And I've got one plan that I want to play with in a bit, but let's do that. And it doesn't have to be that, right? So it could be the angles. So let's say we've got all our squares. Let's go back to a point. And let's say our angular velocity is going to be a curve texture. And let's go 0 and 360. And halfway through here, I'm just going to do that. And just to see what we're doing, let's do 2.
I like
right?
it.
Like playing with curves in particles is awesome. Like I really recommend it. You can do all kinds of cool stuff. All right. So let's carry down the moving things. I used to teach public speaking for a living. Linear velocity. This is just how far are you moving in one direction. Now, this is not the same as original velocity, which is changed by your direction. So let's say we're going to the right, and it's overriding our linear velocity. So honestly, linear velocity and initial velocity is always confusing. I usually just use linear velocity. Radial. Now, radial is a lot of fun. Radial pushes out. So let's say our direction is... nope, that's wrong. We need an initial velocity for this to work.
So if you had a few more particles, we should have seen it going out in a kind of spiral. Is that right?
It should be. It isn't. I want to see why not. This was working earlier. Radial velocity. So yeah, they should be spinning out. I think I've set something somewhere which is stopping it from doing that.
It's quite challenging when you've got an interface that all looks the same. Everything looks the same. It's just something, and the naming's very, very similar all the way down here.
Oh, hang on. I have a curve texture here. Let's just make sure everything is out. No gravity. We don't need spread. We have 8 of them over a second. Let's do 2 seconds. And we'll do 4 for now. Okay.
Oh, what you've got on the screen at the moment I think it's Alien, when they're landing on the planet, they have that kind of effect coming up on the ships.
From what I understand, the first particles actually came from a Star Trek movie with the Genesis probe.
Nice.
Yep. I'm going to be honest. I'm a little annoyed that that's not working. So let's just make a new particle, and I'll show you radials, because that's not a radial effect. New process material, particle material. Let's use squares again. There's reasons. Great. Gravity off. Radial acceleration, say 10. Why are you going up?
It will need an initial velocity as well, won't it? Otherwise, it's
probably. But oh, nope.
There we go.
I don't think so. I think that's just the initial velocity. It's weird. Okay, so radial's not working for some reason. I don't know why not. Let's ignore that for a minute. Tangential is they will spin. Oh, wait a minute. All right, we're at a point. That's why. All right, so this is quite fun, right? So they have no initial velocity, which is why radial hasn't that much effect. But check this out. You can also do negatives.
So it can be sucked inwards.
Or
sucked in at a certain rate, as if it's being sucked down a plug hole. Or a black hole.
Mm-hmm.
Nice.
And if I extend the time a little bit so we can see what we're doing, you should see it'll start coming in and then slow down and try and come back. So yeah, radial acceleration is a lot of fun. As well as radial acceleration, we have tangential acceleration. Tangential acceleration does this. They're going to try and spin out when they're finished. It's not quite the same as orbit, but they will counteract each other. We've also got damping, which is how much are we going to stop the movement. Now, when I use damping, I do it with a curve. So it won't damp at the beginning and it will at the end. All right, so we got those. We've got angle. Now, remember, we already played with an angle before. This is not how much the angle is moving. This is what's the angle when it spawns in. What you can do is if you do 360 and randomness at 1, and let's put this back to a point. Now, if you mix that in with angular acceleration, angular velocity rather.
And that's nice, of course, because if you've got something that's not a square, but a texture or a splat or dust or something along those lines, as will now be demonstrated.
Yep. So it's starting to look a lot more organic. Now, there's stuff we can do to make it look even better. And one of the things we can do to make it look even better, as we're here, is mess with the scale. So scale is 1, right? That's proportional. Obviously, the scale can be 0.5, the scale can be 10, right? Fine.
That's the
So
sun.
far, so good. We can also do random scale, but that's going to be quite hard to see at this scale, right? There's not much we can do with it. What we can do is this. We are going to start, let's say, half, go up to 1, stay there for most of the time, then drop to 0. And this stops doing its flickering thing that we saw before, right? And the reason for that is by the time the particle is dead, there's a bigger particle on top of it that's hiding it. You can do something very similar. Come back. Where'd you go? Stop that. You can do something very similar with color, right? So we could just change the color. Fine. Or we could go to the color ramp and make a new gradient.
That already looks pretty cool.
Right? Now, let's say that's white and that's white. This one is going to be white with no alpha. And this one is going to be white with no alpha. Or maybe they're not white. Maybe we're going to go between colors.
Nice.
So there's already a lot we can do with these. And those are the basic ones. So there's one more you can do, which is hue variation. Think of this as color, but you have less control. Like you're not picking a specific color, you're just picking the hue. And that's just going to, well, if I do 1, we've got all the way around the cycle. Let's put it on random.
Roderick says the initial gradient looked like some sort of serious nightmare stuff. Yeah, the black one could easily fit into a lot of horror movies. The way it has an effect, doesn't it?
And interesting with black, one other thing we can do is we can change how the material is drawn. Right now, we're just overlaying it, right? But what happens if we let's change to a ramp? I'm going to go from wait, no, that's a hue variation ramp. Let's go to our gradient, make a new gradient. There we go. So we're going from black to white, right? Now, if I go to materials, which is under canvas item, and I do a new canvas item thing, I could change from mix to add. And now what it's doing is it's taking the values and superimposing them. But when you do that, black is 0. So if I get rid of that ramp and make this color black, it vanishes. So this is a great way of dealing with alphas and things, but it's also a really great way to make things feel a lot more vibrant, I guess would be the word. So let's go to an energy hoop thing.
Look into my eyes, not around the eyes, but in the eyes.
Oh boy, that was painful. All right. Let's just get rid of the angles. That's not what that looks like. Just make sure I'm not spreading stupid. All right. Oh, it's because they're adding on top of each other. All right, let's do circles. Great. We'll do circles, and we're just going to make them radiate out. Right, so let's go to radial, and we'll say 50. And that needs to be a sphere. So let's go to our sphere. There we go. So if this is just a normal mix, that's what that's going to look like. So let's pick a color for it. Let's say it's nice yellow, mustard color, fine. And then if I add it, where they overlap, they're going to start getting brighter. And this starts looking a lot more plasmatic, right? A lot more organic, because you can actually see the colors clump together. Once again, put it like that. And it's just yellow dots. Put in the add, and you get this magic effect. So when you want that, that's how you do it. Now, you don't always want that. So with all those stuff together, I think that was all the ones I wanted to look at. Let's start. Oh, and you can also use the animation right here. I don't have any sprite sheets. I'm not going to be doing that. But if you're using a sprite sheet or an atlas, that's what you can do.
I could see making an explosion with this as well.
Oh, yeah, easy.